Okay, so let's talk for a few minutes about electric generators. And even though I mentioned it in the last video, I will start from the top again, just in case you didn't watch the last video. So electric generators, we talked about them the other day in class a little. They were invented by Michael Faraday. We've met him before. We met him when earlier in the electromagnetism unit. And all a generator does is it takes mechanical energy and turns it into electrical energy. Okay? And so there is a picture in your textbook if you want to look on page 519. But really what it is you have two magnets, okay, a north and a south pole. You have this loop of wire that's placed between them, okay? And then I'm going to turn the wire. So I'm going to take this edge and I'm going to turn it up around. So as this edge comes up, it's going to leave the magnetic field. So as it comes up out of the page, up here, the magnetic field is going to be getting weaker and weaker and weaker. And so it's a changing magnetic field. And a changing magnetic field is going to create an induced current, an induced EMF, which will create a current. Now I can figure out the direction that the current's going to flow. If I think electron current, then I take my left hand, honest, that's my left hand, and I'm going to point my fingers in the direction of the magnetic field, and I'm going to point my thumb up out of the page because that's what this side is doing. And so as this side comes up out of the page, my palm, I must have done it with my right hand the last time. My palm is going to be pointing down towards the bottom of the page, so the current's going to flow like this. So as it comes up out of the page, the current will flow this way. But as it comes up and the field gets weaker, the B is getting smaller, so the amount of induced current will get weaker. Okay? When it hits the highest point up here, it's going to stop, so there'll be no movement, there'll be no change in field, there'll be no EMF induced. But now it's going to start back down the other side. And as it starts back down the other side, now my thumb has to point into the page. And if my thumb points into the page, and it's this part of the wire that's now over here, because this part has gone around the bottom and it's now on the other side. So this part of the wire is now on this side, and it's now going, the current is now flowing in the opposite direction. So what has happened is you'll get maximum current when you're right dead center in the wire. Then as you either come up out of the page or go down into the page, it gets less and less. When you are at its highest point up here or lowest point down there, then you'll get no induced current, no induced EMF. And then as you start to come back down, then it will turn around. And so that's why you get the sine wave. And so the faster you spin it, then the quicker the field is changing, so the bigger the EMF. The stronger the field, the bigger the EMF. The more loops, the more wire you have in here, the bigger the EMF. So if we want to make a really good generator, we'll put numerous loops in here. We'll have a really strong magnetic field, and we'll spin it like crazy. Maybe I'll hook my puppy dog up to it to spin it so that I don't have to use my hands. Or maybe I'll hook some water coming down off a big waterfall to it so I don't have to use my hands. No matter what we do to spin this loop of wire, though, we're turning mechanical energy, I'm physically cranking out the energy, into electrical energy. It's the exact opposite to what we do when we use a motor. A motor is taking the electrical energy and turning it back into mechanical so that we can get work done. Okay, so that's really all a generator is. So that would have been the second new piece that we would have done in class today. Maybe just read through your notes there. You'll see at the bottom of the page of notes that it says a chart with AC and DC. This is stuff we're going to talk about when you come back on tomorrow or the next day. If we're not in class tomorrow, I'll do a video on transformers, which is the back side of your notes. But these other things I'm going to wait and have the conversation with you. If you're bored, though, maybe look up voltages. Like most of you probably already know that like North America uses different voltages than Europe. So do a little research for me, because I'm going to ask you the next day I see you, why? Why do we use 110, 120 and Europe uses 220? how come there are different frequencies in different countries? And what are those frequencies? Now the frequencies, because this is alternating current, remember? So the frequencies, remember frequency is a measure of hertz, and hertz is really just a 1/second. And frequency, that's what frequency is measured in. And frequency is how many times something happens in a second. Cycles per second. Remember that from Physics 11 with waves. So when we talk about frequency and alternating current, what we're talking about is how many times do I twirl this in a second? How many times does it go around? And so in North America, the frequency of our alternating current is different than it is in countries in Europe. So if you're bored tonight, tomorrow, have power, and it's a snow day, maybe you want to check out what are the different frequencies, what are the different voltages in the different countries, why? Okay, because that's what we're going to talk about next time I see you, along with transformers, and we'll make a chart of AC/DC. Okay? All right. Have a good night.